now I would like to have some discussions about, these are all topics actually, but, adjusted to the topics that have been discussed in AI for 75 years. How much is AI? How much is human intelligence? As I mentioned, the language model and the chatbot are finalized via feedback from humans. GPT 3.5 includes what OpenAI calls RLHF, reinforcement learning with human feedback. And that's a euphemism for many people working on quality assurance, basically. So you have people from OpenAI, physically at OpenAI offices, and people all over the world, God only knows where. And they're all working to finalize the ChatGPT that we are using. So how much is AI, how much is human intelligence? And then if you look under the hood, you see more details. These are humans. These are human people doing this job. Okay, this is an OpenAI paper. Okay. Anyway, the other question that people are discussing, of course, is this leading us to human level intelligence? And here, the main objection is always biology. The human brain is completely different. Neurons are carbon-based organic matter. Each neuron is different. We have more than 100 neurotransmitters. It means there are 100 different kinds of messages that neurons exchange. Grand total is 600 trillion synapses. That's the equivalent of the parameters of an artificial neural network. By the way, our brain is super efficient. 20 watts, that's an estimate. We do everything that you do. That, you drive, you go buy groceries, you cook, you go hiking on the mountains, you play chess, all of this with 20 watts. And the cells use phosphates to transfer energy. So on the right is a picture of a neuron. Down there, there's a list of the most popular neurotransmitters. And down there, there's the chemical diagram of phosphates. And the brain might be even more complex than today's biology can imagine. This is a conversation I had with Gerald Chun. You can find it on YouTube. And he has shown that even the little that we know about neurons could be wrong. For example, neurons could be even more different from each other than we have ever imagined. Apparently, it is not true that every cell has the same DNA. So not only neurons are physically different, but even their DNA could be different. Anyway, so they're just two different systems. And then the dollar in front of 700 is a typo. 700 watts for each GPU. And the human brain, 20 watts for everything. Incidentally, the most important thing, in my opinion, the human brain is a body. And we use two types of signaling. One is synaptic via those neurotransmitters. And the other one is the so-called endocrine signaling via hormones in the bloodstream for long distance communication. On the right is a diagram of the endocrine system. Last but not least, the human brain develops as we live. Right now, training language models is done almost entirely upfront. So our brains are children before they're adults. Incidentally, a question that philosophers should ask is why we all have different brains. Why humans, I believe there's never been two humans with the same brain. Why nature likes that. And incidentally, I think no two humans speak the same language. Yes, we understand each other. Well, we pretend we understand each other, but we all have our own style. In fact, you can probably decide if a letter is authentic or not by judging the style of the letter. If it's written by somebody you know very well, I think I could identify the style of most of my friends and relatives. Anyway, I'm not the only one to doubt, to emphasize that biology and software are different things. Jeffrey Hinton, a personal hero and a hero of many people, he's the one who kept neural networks alive during the dark ages of AI. He also thinks that there's something missing in the current AI systems that he helped create. He and his students wrote the paper in 2012 that started the boom of deep learning. More philosophy, if chatbots like ChatGPT, if you think that they match the human mind in at least in producing fluent language, well, that demystifies the human mind big time. Why? Because language models are designed simply to predict the next word in a sentence. And that's enough to generate sentences that match and even surpass human performance. I mean, that's not a compliment to the human mind. Is it that easy to be intelligent, to be a mind? If that is true, then it is not so special to be a mind. A very simple algorithm can create something as articulate as a mind. So this could be a Copernican revolution, where we discover that it takes very little to do things that we assume were so difficult and so special, like generating fluent language. Now, back to the story of the body. Progress in robotics instead has been disappointing. They do well in the controlled environment of a factory, but in the open-ended environment driving, not so much. It's hard to imagine robots that just share our ordinary life, a supermarket, at the stadium, robots that play soccer. I came up with the Messi test instead of the Turing test. When will a machine be able to perform as well as Messi in a soccer match? So Ex Machina, if you've seen the movie, can't happen because ChatGPT doesn't have a body. I have a picture of this movie because I learned a long time ago, any AI presentation must have at least one picture of a Hollywood movie. So the fact that the body is difficult, not the mind, is interesting because, as usual, what looked easy turned out to be difficult. And what looked difficult is turning out to be easy. We clone the mind, but not, we are cloning the mind, but not the body. It's in quotes because, of course, it depends if you really believe in the power of these new AI systems. So the body is the really difficult problem. By the way, I have a picture of Michelangelo's David, which is now considered pornographic in some schools in Florida. So I don't know if this video will be allowed to stay. The body is the really difficult problem. We may have to reevaluate our bodies. Maybe that's what is really special about us. Yes, I'm aware of the Boston Dynamics robot. This is actually, I was playing, I removed myself from the picture. I was playing with this robot. I am aware of Ishiguro's crazy humanoids, and I'm aware of Sophia, the robot who got citizenship in Saudi Arabia. So it's very far from behaving like our bodies. Now, another question, of course, do we really want to copy the human brain? Or wouldn't it be better, wiser to build a better brain? I, for one, am not really a fan of the human brain. Human brains have so many problems that would take a long time to list all of them. Now it's interesting also to think how we got here. How do we get to the ChatGPT. When I was just born, computers came out. The first commercial computer was in '51, and for a while they called them mainframe computers. They were gigantic computers. A computer was a machine that only specialists could use. You couldn't, as a high school student, I couldn't access and then I'm working at Olivetti in Italy, which was a big corporation. It had a huge mainframe, but you couldn't access the computer. You couldn't even look at it. It was in a room, well protected. You would give your punch cards to a man, and then we would come back a couple of hours later to pick up the printout. Then the microprocessor on the PC changed because everybody could have one. Everybody could have a computer. The internet was another inflection point because now the computer became a communication device, not just a computing device. In fact, most people who use the computer in the 90s, in my opinion, were not doing computation, we're doing communication. And then, of course, the mobile phone, the computer became not only a communication device, but something that is with us all the time. And now computer can even read and write, even write software. So those are the 5 big inflection points that I see in the story of information technology that led us where we are now. Looking back all the way back to the wheel, in terms of technological revolutions, my question is this the first major technological revolution that is not about precision, that is inherently fallible? I mean, think whichever, the printing press, the steam machine, the telegraph, the telephone, the airplane, the car, the radio, the smartphone, whatever. They're meant to do what they're meant to do. I mean, you expect that the books printed with a printing press, they're all identical, precision. When you fly, you expect the plane not to crash. When you turn on the radio, you assume to hear music. So precision, you know. And instead, in this case, when you talk to ChatGPT, you accept the fact that that's not a precise technology. So I wonder if this is true, and if this is heralds a change. Maybe the idea of precision technology has to be precise. Maybe this peaked in the 20th century. We're entering in a new era where we're willing to live with imprecision. Now, another topic is language models are not deterministic, and they use stochastic methods, and they typically yield different results every time. If you ask the same question twice, you get different results. By definition, they output a probability distribution. So the transformer is actually deterministic. But the language model and the chatbot built on top of the transformer is not. There's this process of sampling that introduces, I don't know if I want to call it randomness, but anyway, non-deterministic. So that's I don't know if there are other tools that we use that are not deterministic. It's also interesting to think where it comes from a bigger viewpoint. I mean, there's been a time, I mean, at some point we started using electricity to do things. You know, I'm Italian, so I start with Alessandro Volta's battery. If you're American, you can start with Benjamin Franklin. And then there's been progress in using electricity. You know, in my opinion, the electrical motor is one of the greatest inventions in the history, most influential inventions in the history of the world. And then you add the radio, television, the transistor, and then the transistors help you make smaller computers, and so on and so on. And then eventually, Intel's microprocessor and NVIDIA's GPUs, and then using GPUs, we can run these neural networks. And of course, what led us to the electrical age? Well, there was the scientific and industrial revolution, and you can start it wherever. I mean, I started with Copernicus. You can start with Galileo, whatever. And through that revolution, they went through Newton and so many others. Then eventually, you have you come to the age of electricity. So anyway, it's interesting to see where we're coming from. Now, as I mentioned, this is Moore's law. On the right, the blue one. Moore's law was an exponential growth of transistors, so indirectly of microprocessors, and that technology led us to ChatGPT. But now that we have these language models, their exponential law of progress is even steeper. Progress is even happening faster. So it's interesting to ask where are they leading us? If the microprocessor, if the Moore's law led us to ChatGPT, the progress in things like ChatGPT, that new technology will lead us to what in the same amount of time? Now, I think we have to be careful to answer these questions. In the 50s and 60s, most thinkers imagined that computers would simply get bigger and bigger. You also see it in movies. The computer of the future is just so big because people thought the fact that they're big is actually a special thing. The special thing, of course, was the programming languages. The fact that you can program a computer to do an infinite number of things, potentially solve any problem. So they didn't see it back then. And then when the internet came out, I saw the same thing. Most thinkers envisioned a global brain, which was a fascinating concept. I really liked the concept, but it wasn't the reality. The reality, here I copied the text I've written for a new edition of one of my books because I'm vanity. So I wrote that. So the internet, the real internet that we got is not a global brain, it's anarchy. It's a chaotic, distributed, prosumer-created content, a subculture of internet content, a multitude of micro-narratives in a jungle of advertising and disinformation, an aggregation of autonomous epistemologies, a labyrinth of echo chambers, a far west of trolls and spam. I liked my writing, rarely like my writing, so I copied it, but definitely they didn't see it coming. So I think right now we are at another inflection point where we have to be careful because you really have to understand how it works. And that's also why I think it's important to understand how the transformer works. The people who saw the computers as just getting bigger, they didn't understand, they didn't know that there were programming languages. They didn't know how people were using them. And same with the internet. The people predicting the global brain were not looking at how people were using the internet. So now I wonder if we could fall in the same trap. So why is ChatGPT the fastest growing app of all time? That's a question that I ask people, and people give me different answers. Some people very near me simply say because it's useful. But in my opinion, it's like a pet. It's cute, it's useful, sometimes very useful. It's unpredictable. It's not always reliable, and that also makes it interesting. And it's fun to play with. My opinion, psychologists will know better. But now, what is GTP? ChatGPT. And one could say it's another form of intelligence. That's an easier way to get away with AI. I've been doing this since the beginning. You know, when people ask me, AI systems, are they getting intelligent? It's a different form of intelligence. And we have always coexisted with different forms of intelligence. Dogs, cats, bats can use sniff explosives in suitcases at the airport? Dogs can. Can you catch mice like cats do? No. Can you fly in the dark like bats do and land upside down on the ceiling? No. Even kitchen appliances, the car, the computer, the smartphone, they all do things that we cannot do. And to me, those are different forms of intelligence, different intelligences. And we coexist with them. And some of them are better than us at some things. So in each case, we learn a language to communicate with another form of intelligence. If you go back to prehistory, we learn a language of behavior to live, I don't know, in the savannah with cheetahs and leopards and the environment, friendly or hostile. And unfortunately, we have to learn a language every single time that we buy a device. There's always a learning curve. I was reading a report that more than 50% of returns, I believe, to Amazon, to one of these big websites, is not because the thing didn't work. It was just too difficult to operate. So every single time you have to learn a new language. And yeah, so then now we have a new form of intelligence. And what makes it special, of course, is that it can speak human language. That is new. At the same time, I see ChatGPT also as a mirror. And that's one of the things that made it so fascinating, that these chatbots are behaving just like humans. When they were accused, ChatGPT was accused of making up things, of hallucinations. But humans do that all the time. Ask them anything. What happened? What happened? There was a car accident. What happened? Very few people can tell you exactly what they know, and that's it. Almost everybody has to make something up. And if they're honest, they start by saying, I think that. But in most cases, they don't say, I think that. They just, try to fill the gaps in the ignorance they have about the facts. Well, ChatGPT does the same. So in that sense, it's fascinating. Not only that, ChatGPT learns from the text that we produced. Okay, don't blame ChatGPT if it is sexist, racist, or whatever. It learned from our text. So it's a mirror also in terms of a mirror of our society. It's, in a sense, you can see these generative models as external observers of human society. And, it's, in a sense, it's impressive that they have this naive honesty in telling us what are our collective beliefs, biases, dogmas, superstitions, and so on. By the way, all these pictures have been generated with stable diffusion, which is one of these generative models. So I just entered, I don't remember, make things up, mirror, whatever. And the other one, I entered the population of people, different jobs, whatever. So we are not interacting. When we interact with ChatGPT, we are not interacting with the equivalent of one person. We are interacting with the equivalent of all the people, alive and dead, whoever posted something on the internet. Plumbers, cleaners, engineers, shops, teachers, farmers, and of course, racist criminals, politicians, lawyers. They write a lot. So Noam Chomsky, great linguist, is still alive, said these systems are maybe good engineering, but not very good at science. He doesn't like them. Yeah, maybe they're not very good at science, but maybe they're good at social science. Incidentally, Mikhail Kosinski wrote a paper where he asked, as a theory of mind emerged in large language models, worth reading. And again, in the spirit of we created a mind. One of my tests is, does it have a sense of humor? We humans rarely interact seriously. The vast majority of interactions are actually with a smile of laughter. ChatGPT is interesting. It did understand this joke. This is something I heard on a soap opera, TV comedy. A wife is reading a magazine while the husband is sitting next to her, and the wife reads this page and says, how would you like to spend your evening? A, with your wife. B, and the husband goes, B. So why is it funny? And guess what? ChatGPT explained to me why it is funny. So it did get it. Unfortunately, when I asked ChatGPT to make a joke, make a joke about Italians, make a joke about this and that, the jokes were really horrible. So what does ChatGPT tell us about our brain? That's another good question. ChatGPT uses something similar to what our brain uses, loops of feedback. Very complicated, many. But at the end of the day, loops of feedback. So does this tells us that loops of feedback inevitably result in a fallible mind, unreliable, prone to hallucinations, mistakes? And if so, why did nature create imprecise beings? It's when we think of things, we actually use imprecise quantities. When we say Ed is tall, well, Ed is not tall. Ed is 183 point something centimeters tall. The word tall is imprecise. So philosophers have been discussing these things for a long time. So in that case, the question, if humans are the most rational animal ever, the question is why the most rational animal ever needs irrational hallucinations, such as religions. At the end of the day, religions, no offense to religious people, but I don't think Jesus resurrected after 3 days, and I don't think that Muhammad was a prophet who spoke with Allah and so on. At least it's not very rational. And why do we lie and cheat? And humans are probably the peak of cheating in the animal world. And so thankfully, ChatGPT doesn't have emotions, because emotions further escalate how unreliable and irrational we humans are. And what does ChatGPT tell us about our brain is also in terms in general. Mastery of language is no guarantee of mastery of other cognitive skills. And that's something we probably have subconsciously known for a long time. Somebody who talks very well is not necessarily very intelligent. But ChatGPT is there to show it to us. They can be very convincing and very wrong. And of course, mastery of language is no guarantee of truth, honesty, decorum, and so on, qualities that we humans normally value. Another way to look at it, does it pass the Turing test, the famous Turing test? If I cannot tell which one is the machine and which one is the human being, then the machine passed the Turing test. Well, it writes better than most humans. It makes things up, but so do humans. The problem I see is that it doesn't have opinions. That's how you could catch it. If I ask a human being, what is your opinion on, well, right now there's a war in Ukraine. What is your opinion on the war in Ukraine? Why did Putin start the war? What does Putin think right now? What should the United States do? Humans have opinions. It's difficult to find somebody who just says, I'm sorry, I'm not competent, I don't know. Humans have opinions. And ChatGPT is fine-tuned not to have opinions. So therefore it fails the Turing test, no matter how well it speaks, because it doesn't do the one thing that humans do, be opinionated. This is what ChatGPT answers if you ask for an opinion. My question is, could we do the opposite and just be honest, let the machine have opinions, let the machine tell us the opinions. See, it's scary because those opinions will be learned based on the training. The training is based on the text that we produced, on what we say and write. But it would be really fascinating to have a machine that actually has opinions, and then maybe we'll pass the Turing test. So this is another old story. John Searle is a philosopher, I think he's still alive, and he came up in 1980 with the idea of the Chinese room, implying whatever the machine does, no matter how intelligent the output looks like, the machine still doesn't know what it is doing. Okay, you take somebody who doesn't know Chinese, give him the rules to speak Chinese, and if it has all the rules that you need to speak Chinese, this person who doesn't know Chinese will produce a good Chinese output that will sound like coming from a Chinese speaker. I'm simplifying. So that's an interesting, it's always been an interesting philosophical point of view. Paul and Patricia Churchland already responded. So I don't want to get into a long debate. I just say that I know that it's a debate. It's not just, it didn't stop there. The point is now with ChatGPT, we realize something that was only implicit back then, that the fake Chinese speaker also needs to have the knowledge about everything. The knowledge, it has to be, a chatbot is both a language speaker and a knowledge base. In a sense, it's an encyclopedia. Unfortunately, when the encyclopedia doesn't give the answer, it comes up, makes things up. But to work in that kind of scenario, you have to think of somebody who not only has the rules to speak Chinese, but also has the knowledge, factual knowledge, a lot of factual knowledge to be credible. And this, of course, brings us to the discussion about knowledge. How is knowledge created? What happens when most of the text on the internet have been written by chatbots? I mean, chatbots right now are in a sense imitating human text. But if we keep posting them on the internet, and by the way, they could generate millions, then at some point there are more chatbot generated text than our text. So that's going to be an interesting inflection point. And it's also, you know, the definition of knowledge has also been a big topic of discussion in philosophy. And my question is, what is the difference between hearsay and scholarly research? ChatGPT is somewhere in between hearsay and scholarly research. So there seems to be a continuum there. And for those like me who follow music, how's ChatGPT different from remixing and sampling in music? A lot of music today is made by remixing existing music or using samples from existing music. Now, on the positive side of this discussion on knowledge is the fact that AI can potentially break these language barriers. I mean, I think if we could have speech-to-speech translation, the big companies are working on it, so that every speech in the world, I can listen to every speech in the world that I want to listen to. If Xi Jinping gives a speech in Chinese, I don't have to read in the New York Times the English summary of his speech. I can listen to it directly. And text-to-text, the same. Improved text-to-text translation could provide us access to all the scholarly articles ever published. So the amount of knowledge available in every single language could could escalate exponentially. And every new book would be automatically translated in every language. Actually, only a very teeny percentage of the books published in non-English language are translated into English. And if you look at the numbers, it's staggering. The vast majority, gigantic majority of books are not translated into English. And I'm talking about one of the main languages in the world. So imagine how many non-Telugu books are published are translated and published in Telugu and so on. Now, coming to the humanities, and this I left for last, but maybe it should have been first. What can the generative models do for humanities? And I can see many creative things. So first of all, right now, this idea comes from my friend Jonathan Kitts. Right now, you have to read the book. In the future, you could converse with the book. You take the book, you create a generative model out of that book, and now you can ask questions. I don't know, Pinker wrote this wonderful book. Can't remember the title. Very thick, about basically about the progress of violence and history. It proved that actually we live in the most peaceful society ever. Well, instead of reading the whole 1,000 pages, whatever, how about I ask questions about, violence in the Middle Age, or why you think World War II was not so deadly, and so on. And then you can even create generative models based on everything that somebody has written. And here in the slide, I used Balzac because Balzac wrote a lot of novels. If you build a generative model from Balzac's novels, because those are novels, those are not facts about it, but they pretty much represent the society of the time, and especially the beliefs of the time. And in particular, Balzac's own biases also in terms of what is important, what is not, how a daughter should behave to her father, and so on. So that would also be an interesting application. And if you keep a diary, you could also have if you get your own writings, you could build a generative model about your own writings. And then again, my friend Jonathan came up with the idea, how about training a generative model on an encyclopedia of the era? And here I just expanded. How about creating a generative model on all the books published in a specific age or country or whatever, and then you would be able to replicate the mindset of that age, and so on. So you could do the same with any discipline, any scholar. You could create generative models on specific disciplines with specific, cloning the mindset of great philosophers and so on. In a previous presentation, I've done this several times. I've discussed deep learning, which is the technology underlying these generative models, and deep thinking. And my claim is that deep learning is shallow thinking about big data. And what we do, the humanities do, is deep thinking about small data, meaning I give you just Kierkegaard, and the humanities spend a lot of time, conferences, papers, books, discussing small data about Kierkegaard. Deep learning does the opposite. It takes a huge data set, 1 million images, or all the text on Wikipedia and so on, and then does what? Very superficial thinking, so shallow thinking. So this was the example I used back then. This was incredible, already 10 years, when this system came out from Stanford and Google that recognized cats in in YouTube videos, that was an impressive achievement. But my point was, a human being does deep thinking. What's deep thinking? Well, for example, why are there so many cats on the internet? That's apparently back then there were 2 million YouTube videos of cats with 25 billion views. Why are there? Why we like so much to post cats on the internet? When they asked Tim Berners-Lee, the inventor of the World Wide Web, the thing that surprised him about the internet, he replied, kittens. He didn't expect that so many people would talk about cats on the internet. Well, and then deep thinking. So which animals have been charismatic in history? And then we go back and we can talk about cave paintings, which animals were taken to the Colosseum. We can decide, oh, are there cats in the Bible? Well, it turns, as far as I know, no. Which animals were in the menageries? Big cats. Automata, has anybody built an a robot that was a cat? Actually, birds were the preferred thing. And the cartoons, well, the most famous cartoon is actually a mouse, which is almost an insult to cats. So that's deep thinking. Why? Does it have to do with the unique role of cats in religion, philosophy, entertainment, science? Well, there's one cat god in Egypt. Of course, there's Schrodinger's famous cat that is both dead and alive. Jacques Derrida's cat was famous. And Andrew Lloyd Webber made a musical Cats. So putting all these things together is what we humans do. Historically, guess what? I found out the very first videos were videos of cats. Edison made a video of boxing cats, and the first video published on YouTube had cats. So that to me is deep thinking, which that's still unique to the humanities. That's what humanities do, and that's different from what machines are designed to do. Now, coming to the closing, dangers of ChatGPT. Well, dangers of ChatGPT, this is a reminder of where the real dangers are. ChatGPT does only one thing, it talks, okay? Is there any evil that ChatGPT can do that humans cannot do? I don't see it. It's humans that act. ChatGPT talks. If there's any evil that can come out of ChatGPT, it's because a human used it to do something evil.